Welcome to another lecture video on series of non-negative terms. In the previous lecture, we already discussed two tests for this type of series, namely the integral test and the comparison test. In the case where we are not able to get any conclusion in using these two tests, we may try to use the following test, called the limit comparison test. As written in the theorem, we require the series of a sub n and the series of b sub n to be series of positive terms. Let's look at the three cases that may happen. The first case tells us that if the limit as n goes to infinity of a sub n over b sub n is equal to L, a positive real number, then both series summation of a sub n and summation of b sub n converge, or both series diverge. For the second case, if the limit as n goes to infinity of a sub n over b sub n is equal to 0, and if the summation of b sub n converges, then the series of a sub n also converges. For the third case, if the limit as n goes to infinity of a sub n over b sub n is equal to infinity, and summation of b sub n diverges, then the series of a sub n also diverges. Just like in the comparison test, you will need some skill in choosing the series of b sub n for comparison. As you will see in our examples, one may use the geometric series or P series for the series of b sub n, but it may not be the case for some other problems. For our first problem, let us try to use the limit comparison test to determine whether the series given as follows converges or diverges. Take note na positive ang terms nitong series. So pwede natin gamitin yung limit comparison test. Subukan natin gamitin ang series na summation 1 over cube root of n as n goes from 2 to infinity for comparison. Setting a sub n to be 1 over cube root of n plus 1 and b sub n to be 1 over cube root of n, we have the limit of a sub n over b sub n equal to the following limit. I-divide lang natin ang numerator at ang denominator by cube root of n to get the following limit. And as n goes to infinity, papunta lang ito sa 1, which is greater than 0. Also, alam natin na divergent ang series 1 over cube root of n equal to infinity from our previous lecture. Kaya by limit comparison test, the series summation 1 over cube root of n plus 1 also diverges. Ginamit natin dito yung unang case sa ating theorem. For our second problem, alamin natin kung convergent or divergent ang series na ito. Again, positive ulit ang terms nitong series, kaya walang problema. And we let a sub n be equal to 4n squared plus 3n minus 1 all over 3n to the 5th plus n. Para naman sa b sub n, ang isang trick na pwede natin gamitin for rational functions ay i-divide natin ang variables na may pinakamalaking exponent sa numerator at denominator. Dito sa a sub n, ito ay ang n squared over n to the 5th, which is equal to 1 over n cubed. Kaya susubukan natin piliin kay b sub n ang 1 over n cubed. Again, i-evaluate lang ang limit ng a sub n over b sub n as n goes to infinity. Tapos, pag sinimplify natin ito, makukuha natin itong limit. Kagaya ng ginawa natin sa naunang example, i-divide lang natin ang numerator at denominator by n to the fifth para makuha itong limit na ito. And as n goes to infinity, papunta lamang ito sa 4 over 3, which is positive. Since summation of 1 over n cubed is a p-series with p equals 3 greater than 1, it is convergent. By limit comparison test, the series summation 4n squared plus 3n minus 1 over 3n to the fifth plus n also converges. Napakita natin sa examples na ito kung ano ang dalawang senaryo na pwedeng mangyari kapag ang limit ng a sub n over b sub n ay isang positive real number. For our third problem, tingnan naman natin ang series na summation from n equals 2 to infinity of 1 over ln n quantity squared. Take note, ln n quantity squared is greater than 0 for all n greater than or equal to 2. Again, let a sub n equal to 1 over ln n squared. Tapos piliin natin si b sub n. Kailangan natin ng practice sa pagpili kay b sub n lalo na sa mga problem na katulad nito. Ang isa pang trick na pwede nating tandaan ay pumili ng b sub n na kung saan alam natin kung paano kunin ang limit ng a sub n over b sub n. In this case, susubukan natin ang b sub n equal to 1 over n. I-evaluate natin ang limit ng a sub n over b sub n as n goes to infinity. Tandaan natin that n is a natural number at para magamitan natin ng L'Hopital's rule itong problem dahil ang form niya ay infinity over infinity, kailangan muna natin isulat ito as a limit of some real number x going to infinity. Pagkatapos, gamitan ng L'Hopital's rule, equal lamang ito sa limit ng 1 over 2 ln x times 1 over x. Kinuha lang natin dito ang derivative ng numerator at denominator. Simplifying, we get the limit of x over 2 ln x. Again, itong limit na ito ay of the form infinity over infinity. Kaya gagamitan natin ulit ito ng L'Hopital's rule para makuha ang limit ng 1 over 2 over x. Or in short, limit of x over 2, which is equal to infinity. Ito yung case 3 sa ating theorem. Alam natin na ang harmonic series na summation 1 over n diverges. Kaya base sa case 3 ng limit comparison test, the series summation 1 over ln n squared also diverges. Tandaan din natin sa case 3 na mangyayari lang ito kapag divergent si summation of b sub n. Kung sakali limit ng a sub n over b sub n ay infinity, pero ang series ni b sub n ay convergent, wala tayong conclusion base sa theorem ng limit comparison test. Another example for limit comparison test, we will consider the series summation n equals 3 to infinity of ln n over n squared. Positive ulit ang terms nitong series. For item number 1, ipakita natin kung bakit hindi gagana ang limit comparison test kapag ang harmonic series ang ginamit for comparison. For item number 2, ganun din ang gagawin natin, pero ang gagamitin na series for comparison ay ang P series with P equals 2. Finally, for item number 3, pipili tayo ng appropriate series for comparison para alamin kung convergent or divergent itong given series. Again, for number 1, dahil harmonic series ang series for comparison, we let a sub n to be 1 ln n over n squared and b sub n to be 1 over n. Kaya ang limit ng a sub n over b sub n as n goes to infinity ay equal lang sa limit ng ln n over n. Again, this is of the form infinity over infinity. Kaya isusulat muna natin as a limit of a real number x going to infinity. Using L'Hopital's rule, we get the limit 1 over x, which is equal to 0 as x goes to infinity. However, the series summation of 1 over n diverges. At base sa second case ng limit comparison test, wala tayong conclusion na makukuha dito. Hence, limit comparison test fails. For item number 2, we let a sub n to be ln n over n squared and b sub n to be 1 over n squared. Kaya ang limit ng a sub n over b sub n ay equal lang sa limit ng ln n. Alam natin, as n goes to infinity, ang ln n papunta rin lamang sa infinity. But however, the series summation 1 over n squared is a p series with p equals 2, so it is convergent. Base sa case 3 ng theorem, limit comparison fails yet again. Finally, for item number 3, let a sub n to be ln n over n squared. At subukan natin gamitin ang b sub n equal to 1 over n to the 3 over 2. Notice that pinili natin ito dahil n less than n to the 3 over 2 less than n squared at may transition sa behavior ng harmonic series na series 1 over n sa item 1 at sa p series na series of 1 over n squared in item number 2. Kaya ito ang gagamitin natin for comparison. Again, kailangan ng practice para makuha ang tamang series for comparison. So now we take the limit of a sub n over b sub n. And after simplifying, we just get the limit of ln n over square root of n. Again, this is of the form infinity over infinity. Kaya isulat muna natin as a limit x going to infinity of ln x over square root of x, where x is a real number. Tapos, gamitan natin ng L'Hopital's rule. So, we get the limit of 1 over x all over 1 over 2 square root of x. And simplifying, we just get the limit of 2 over square root of x as x goes to infinity. Alam natin na papunta lang ito sa 0. Alam din natin na yung series na 1 over n to the 3 over 2 ay isang p series with p equals 3 over 2, kaya ito ay convergent. Base sa case 2 ng limit comparison test, summation ln n over n squared is also convergent. Here are some exercises in using the limit comparison test. So far, natapos na natin ang discussion sa convergence tests for series of non-negative terms. Ito ay yung integral test, comparison test, at yung limit comparison test. Sa susunod na lecture video, aalamin na natin ang iba pang series test, pero magfo-focus na tayo sa series with negative terms. Para hindi kayo mahirapang pumili kung anong test ang dapat gamitin for a given series, simulan natin na mag-solve ng ilang exercises kagaya ng mga ito.